Hi, welcome back. And today we are going to discuss about Kirchhoff law. So first of all, we have to understand what are the different types of Kirchhoff laws. So there are two types of Kirchhoff law. One is called the Kirchhoff current law. Another one is called the Kirchhoff voltage law. So the Kirchhoff current law is nothing but an conservation of charge. So it states that the sum of entering current which is equal to the sum of leaving current in a junction, or it may be node. And the Kirchhoff voltage law is nothing but an conservation of energy. It states that the sum of voltages around a closed loop which is equal to zero. So in the empathy stage, we have there is a struggle to visualize and to understand the Kirchhoff laws. So here, now we can see this image. So this is an path. This is called point A, and the point A. Then further, it will be divided into three sections. One is a point B, another one is point C, another is point D. So here, this is nothing but in a circuit. In a circuit, the total current flowing through the circuit, which is divided among all the parallel branches. So the Kirchhoff current law, which is applicable only in the parallel circuit, not in the series circuit, because in series circuit the current is always same. So the current law which is applicable only in the parallel circuit. So here the sum of entering, that is nothing but an point A, which is equal to the sum of leaving, that is point B plus point C plus point D. Okay. So here in the defined stage, so we have to understand the principle of conservation of charge and conservation of energy. So and we have to implement and so that we can able to analyze in the series circuit, parallel circuit, and many complex circuits. Okay, so here we have to develop the KVL and the KCL equation to determine the current and voltage in the particular branches or loops, so that only we can able to create an practical parallel circuit design. So in the ideate section, now we can take, so this is a water analogy. So here, this is nothing but Q1 is nothing but the entering of water, and the entering of water is further divided into three sections. One is Q2, one is Q2, another one is Q3, and another one is Q4. So the amount of water which is entering through Q1, the total amount of water which is entering through the Q1, and all the water can be divided into three sections. One is Q2, Q3, and Q4. So the amount of water entering, which is equal to the sum of all the sum of leaving water. Okay, so the leaving water both are equal. So this is called a junction. So in this junction, so there is no storage of water, a storage of current. Okay, and another example you can take here. So this is one of the junction. Okay, so this is a four corner junction. Many vehicles are coming from the north side, east side, south side, west side. So all the vehicle, you can take here. So here one vehicle is entering here. That vehicle can be taken left, and that will be goes left. And here the two vehicles are coming here. Okay, and here one vehicle is going in this direction, another one vehicle is coming in this direction. So just you can imagine, so the sum of entering vehicle which is equal to the sum of leaving vehicle in a junction or in a node. So this is nothing but an Kirchhoff current law. Okay, so here you can take, this is a junction. So here I2, I1, and these and I3. So these three are the incoming current. I1, I2, I3 are the incoming current. So I1 plus I2, I3, which is equal to I4 and I5 are the leaving current. So I1 plus I2 plus I3, which is equal to I4 plus I5. You can take this direction, this side. So minus I4 minus I5. So the algebraic sum of current in a junction is 0. So here the current entering is a positive sign and current leaving is a negative sign. Okay, so it can be applicable only in a junction or node. And the Kirchhoff voltage law. So the voltage law is applicable only in the closed loop. Only in the closed loop. Okay. So in a closed loop, the algebraic sum of voltage in a closed loop is zero, or it may be called as the sum of potential rise, which is equal to the sum of potential drop. Suppose in a closed loop, so suppose it contain any voltage source, the voltage source is nothing but potential rise. So the amount of voltage which will be given, the energy supplied, which is equal to the energy consumption or the voltage drop across each resistor. So now you can come here, imagine AB or one of the branch. AB is one of the branch and BC is second branch, CD is third branch and DA is the fourth branch. So here the voltage across AB, voltage across BC, voltage across CD, voltage across DA, so which is equal to zero. The algebraic sum of voltages in a closed path is zero. This is nothing but in voltage law, it is applicable only in the loop. That is nothing but in closed circuit. Okay, so you can do the prototype and test. That is nothing but you can construct and circuit with known values like 1 kilo ohm, 2 kilo ohm, 5 kilo ohm, etc. So, and you can do the theoretical calculation by applying the Kirchhoff voltage law and Kirchhoff current law to predict the value, and verify using some of the instrument like a multimeter or voltmeter or ammeter, etc. And you can compare the theoretical value with the practical value so that you can see the both are same only. And these are the few real world applications in the power distribution side and power PCB design and the battery management system and the telecom network. So this is a mind map. So here there are two types of law: Kirchhoff current law, which is applicable only in the junction or node, and the Kirchhoff voltage law, which is applicable only in the loop, that is closed circuit. And these two can be applicable in the problem solving to determine the unknown voltage, current, and power, etc. And the sign convention, the polarity, the entering is positive and leaving is negative, like that. And this is a Q&A challenge. So can Kirchhoff law be applied to AC circuit with the reactive component? Okay, how does phase angle affect the analyze? Okay, and so the next one, what happens to KVL application in circuits with a time varying magnetic field? So you can put your answer in the comment section, and this is an assessment. So here you can see the circuit. Here the R1 value is given, R2 value is given, R3 value is given. So the all the R1, R2, R3 which are connected with a 12 volt battery. Okay, now you can apply the Kirchhoff law to find the current through R2. So you can apply the Kirchhoff law and you will get the current through second resistance is nothing but 0.24 amps. And these are the few references for this topic. Thank you.